Once upon a time, it was the farthest and ninth planet in the solar system. But astronomers removed this small world from planetary status. A new classification was introduced for celestial bodies in the solar system: dwarf planets. Pluto is now a celestial body in this classification. Many Pluto enthusiasts, of course, were not pleased with this situation and still consider it a planet. However, regardless of all these classifications, Pluto remains one of the most mysterious and fascinating places in the solar system. With its heart-shaped icy surface and active geology, it continues to astonish astronomers. Its orbit around a common point with its twin moon Charon and its other 4 moons makes this mysterious dwarf planet even more intriguing. In this video, we will delve into the depths of Pluto and embark on an extraordinary exploration of its 5 moons. If you are ready, let's begin. When Uranus was discovered beyond Saturn, astronomers believed that there must be other new planets and began observing. Sure enough, another new planet was discovered and named Neptune. Astronomers naturally continued their observations and noticed some peculiarities in Neptune's orbit. They interpreted this as meaning that there could be another planet beyond Neptune, and their work gained momentum. However, finding this new planet would be quite difficult. From the beginning of the 20th century, with the development of observation instruments and the construction of larger telescopes and observatories, the space began to be observed with much greater precision. This led to many discoveries. One of the most notable of these discoveries was made in 1930 by a young astronomer named Clyde Tombaugh. Tombaugh had discovered something that many astronomers had been searching for in the solar system: the 9th planet. This discovery was as difficult as finding a needle in a haystack, but Tombaugh succeeded. The planet was named after the god of the underworld in Roman mythology, Pluto. This name was probably given because Pluto is so far away that even sunlight has difficulty reaching it, making it very dark. Pluto was accepted as the 9th planet in the solar system from that date onwards. However, observations made over the years revealed that Pluto was quite small and light, even lighter than the Moon. Starting in the 1990s, Pluto-like celestial bodies were discovered in the region known as the Kuiper Belt, beyond Pluto. In fact, the celestial body named Eris was even larger than Pluto. Since it was predicted that many more Pluto-like celestial bodies would be discovered in the Kuiper Belt, astronomers considered creating a new classification for these celestial bodies. In 2006, the International Astronomical Union decided to change the definition of a planet and placed Pluto-like celestial bodies in the dwarf planet category. According to astronomers, a celestial body must meet 3 conditions to be considered a planet. 1. The celestial body must orbit the Sun. 2. It must be spherical in shape. 3. Its orbit must be free of other celestial bodies and must be cleared. Pluto met the first 2 criteria, but it did not meet the third. This is because many celestial bodies in the Kuiper Belt are located in Pluto's orbit. Since the same situation applies to other Pluto-like celestial bodies, these celestial bodies were classified as dwarf planets. Although Pluto lost its planetary status, this did not change its importance in the solar system, of course. In fact, this was not the end of its story, but the beginning. Pluto is quite small, but its surface hides incredible details and has a very complex structure. Its diameter is smaller than that of the Moon, approximately 1,477 miles, or 2,376 kilometers. Its mass is 2/1000th that of Earth, so it is both quite small in diameter and quite light. When compared to the Earth's diameter, it is almost half the size of the South American continent. Pluto's orbital period, the time for one complete revolution around the Sun, is about 248 Earth years. This is because Pluto is very far from the Sun. Because of its elliptical orbit, it is sometimes closer to the Sun and sometimes farther away. This long orbital period makes it one of the slowest rotating dwarf planets in the solar system. Discovered in 1930, Pluto has not completed even one revolution around the Sun since then. After its first discovery, it is expected to complete its full orbit in 2178. Although its surface is covered with frozen nitrogen, methane, and carbon dioxide ice, this world is not as lifeless as it appears. In January 2006, the year it was demoted from planet status, NASA launched a spacecraft named New Horizons to explore trans-Neptunian objects. This spacecraft reached Pluto in 2015 and sent back astonishing images to Earth. On Pluto, ice mountains resembling Earth's glacial mountains, nitrogen plains, and active geological structures were discovered, with heights exceeding 3,000 meters. Among these images, the most striking region was the heart-shaped Tombaugh Regio, named after Pluto's discoverer. Just to the left of this region lies Sputnik Planitia, a vast frozen sea of nitrogen. Pluto's surface is so young that it has almost no craters. For this reason, astronomers believe that Pluto has an active geological structure. In fact, it is estimated that Pluto's depths are much warmer, so it may even have an ocean. Contrary to popular belief, Pluto is not a frozen rock, but a constantly changing and living world. Pluto's surface is covered with ice, but it has a very impressive and thin atmosphere. Its atmosphere consists mainly of nitrogen. Gases such as methane and carbon monoxide are also present. The reason Pluto has an atmosphere is because of the evaporation of ice on its surface. Its atmosphere is so thin that the atmospheric pressure on the surface is 100,000 times less than that on Earth. So, even though it is impossible to breathe on Pluto, its pale blue atmosphere can offer a mesmerizing view. In 2015, shortly after the New Horizons spacecraft left Pluto, it sent images of its atmosphere back to Earth. The sunlight in the background clearly revealed Pluto's hazy atmosphere. In this sunset-like image, the atmosphere appears to emit a blue light. The most interesting feature of this atmosphere is that it is in a constant cycle with Pluto's surface. When Pluto approaches the Sun, the ice on its surface melts or sublimates into gas, and when it moves away from the Sun, these gases in the atmosphere freeze again and fall back to the surface. Another peculiar feature is that Pluto completes its rotation around its own axis in 6.5 Earth days. So, if you were on Pluto, you would have to wait almost a week for a day to pass. Pluto is not alone in such a distant realm. It has 5 moons accompanying it: Charon, Nix, Hydra, Kerberos, and Styx. In fact, Charon is so large that its diameter is half that of Pluto. We can say that it is literally Pluto's companion moon. The fact that Pluto has such a relatively large moon makes it different from other dwarf planets, and even planets. Due to Charon's size, it orbits around a common center of mass with Pluto. These centers of mass are also called barycentric. These two celestial bodies appear to dance around each other. Some astronomers consider Pluto to be a binary planetary system. Pluto's other 4 moons also orbit around this common barycenter. Charon's surface has many fractures and deep valleys. These surface structures are thought to have been caused by movements within Charon's interior during its formation. Scientists speculate that there may be a frozen ocean deep within Charon. Charon is very similar to Pluto in both its physical structure and chemical properties. Pluto's other 4 moons, Nix, Hydra, Kerberos, and Styx, are quite small. Their irregular, asteroid-like structures suggest that these moons may be either fragments of an ancient collision or that Pluto may have captured them from the Kuiper Belt. Due to their small size, these moons wobble in their orbits due to the gravitational pull of Pluto and Charon. Despite its small size, Pluto's system, along with its moons, makes it unique in the solar system. Much of what we know about Pluto was learned from the New Horizons spacecraft, which flew by Pluto in 2015. Launched in 2006, the spacecraft began its 9.5-year journey and reached Pluto on 14 July 2015, where it began to study and photograph the surface in detail. The surfaces of its small moons, and especially its largest moon Charon, were also photographed with unprecedented clarity for the first time. New Horizons showed us that Pluto, in this distant corner of the solar system, is not a lifeless, frozen rock, but rather a complex and dynamic world. The surprising part is that all these discoveries were made during a brief flyby, lasting just a few hours after a 9.5-year journey. Although Pluto is no longer officially a planet, it is still of great scientific value. It provides us with detailed information about trans-Neptunian objects and the Kuiper Belt. This belt is filled with frozen and rocky debris that formed billions of years ago. It is like a fossil collection that carries traces of the entire history of the solar system. Pluto's internal structure, moons, and atmosphere give us clues about this past period. Its active geology and potential underground oceans show us how dynamic these small worlds can be. Additionally, these missions to Pluto serve as a stepping stone for future explorations of distant worlds. In fact, after leaving Pluto and diving into the depths of the Kuiper Belt, New Horizons also made a brief exploration of an asteroid named Arrokoth and sent its photographs back to Earth. Pluto is small, but the knowledge we gain from it plays an important role in our understanding of the solar system and beyond. If you enjoyed our journey to this mysterious world, don't forget to like the video and subscribe to the channel. You can watch our other astronomy and space-themed videos and documentaries at the end of the video and the links below. Keep looking at space with curiosity because there is so much more to discover. See you in the next video.